This is Ken Rosever. We're going to talk about comparing means without calculation. And it doesn't seem like it would be possible to compare means or averages without calculating anything. And it's true that it's not possible to do it without calculating anything. Um, but we can certainly um, do it with a minimum amount of calculation. Well, how do we compare these guys? They give us a visual here. Each one of these blocks represents a element in the sample. So you can see as you look here, let me get a thicker pen. Here we go. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements. 2, 3, 4, 5, 6, 7, 8, 9. There's 9 elements in each sample. 9 elements in each sample. Okay, and the normal process is take the for mu. Actually, I'll just go the normal way we find mu. Where's my eraser? Eraser. The normal formula for mu for the mean. You guys learned back in like middle school. They didn't give it to you like this, but it's mu is the sum of all the values divided by n, which is the number of values. So in this case, if we actually added it up, we'd go 2 plus 5. Let me write it over here. For A, we go 2 plus 5 plus 3 times 6, because there's 3 of those guys, plus 2 times 7, plus 2 times 12. And that would give us a total. That would be the top, the numerator. And we take that total and divide it by 9. Well, we're not actually interested in that total. We're just interested in knowing which one's the biggest, which one's the smallest, and what's the order. So is um, the average of A biggest, the average of B, the, let's use the stats word, the mean of C, or the mean of D, which is the biggest, or the largest, which is the smallest. What order should we put them in? In order to do this without doing much calculations, we look at what do they have in common. So I'm going to pick a highlighter over here. And what I notice is that all of them have a little square over to the left. All of them have this person number 2 in them. Or, this kid who's 2 years old. Maybe this is a sample of, neighborhoods and the number of children they have in them. Who knows? We'll just say that's what it is. All the neighborhoods have a 5-year-old in them. So they have that in common. Every one of these have a 5-year-old. Every one of them has 3 6-year-olds. If we're going with that. And 2 7-year-olds. So this little clump of 6 here, is common to all of them. These 6 boxes are part of all 4 pictures. Let me do it over here. Alright, those 6 are in there, and they're also in here. So since every sample has 9 elements, what accounts for the difference is not the stuff that's shaded in blue. So we don't even need to know the total of what's in blue. In fact, we can just go call it B for blue. There we go. This whole thing is B. Well then, this whole thing is B. This whole thing is B. This whole thing is B. So the only thing that accounts for the difference are these guys over here in this picture. Are these guys over here in this picture. the 8 and the 11 in this picture and the 10 and the 11 in this picture. So if we were to write an algebraic expression here for what is the mean, we would say it's b plus 12 plus 12. So we go, this one is b plus 24 divided by 9, right? That would be mu of a. This one would be b plus 11 plus 12 is, there's 23 there. So b plus 23 divided by 9. This one down here would be, let's see, 8 plus 11 is 19. So the mean of C would be b, or, whoops, b plus 19 divided by 9. And finally, the mean of D would be b plus 10 plus 11 is 21. So b plus 21 divided by 9. So whatever this total is, b plus 21. This one is b plus 19. The a is b plus 24. And we see that we don't even have to know what the values are now to know which one's the biggest. Since the denominators are all the same, since we have the same number of elements in each one, the one that is the biggest is the one with the biggest numerator. Which one has the biggest numerator? 19. Is b plus 19 bigger than b plus 21? No, 21 is bigger than 19. B is the same, so let's see. The mean of C is smaller than the mean of D. Go up here to the mean of B. Oh, that's a 23. Right? This is a 23. Over here, it's a 24. Ah, the biggest one is the mean of A. So we can write our answer two ways. Putting them in order. Let me find my pen. I'm going to go a little thicker with my pen. Let's make it 0.7. Okay. We can say that the mean of C is the smallest. So we put the arrow that way. What's the next smallest? D, B, and then A. And the reason is they all have a B, but this one had the 19, this one had 21, this one had 23, this one had 24. Okay, so we could write it like that, or conversely, we could say mu of A is greater than mu of B, who is itself greater than mu of D, which is greater than mu of C. And that's how you do it. That's how you compare means without, not without any calculation, but without um, figuring out what the actual mean is. There is some calculation in there, but you never actually have to figure out what any of these values are to know that C is bigger than D is bigger than B, or C is smaller than D is smaller than B is smaller than A. And I hope that was helpful to you. And I guess that's all for now. You know what I should have done? I should have done that. Isn't that nicer? Okay, so this is, where's my pen? This is Ken, signing off. Mm, Adios.